All right, let's see what we're going to tell psychonomics. This is an Excel file. Actually, let me save this as a CSV just to save us the problem of sharing code. Let's see, save as. So we have to use different packages because we have some differences between the versions we use. I'm just going to call it CRT. And because sometimes I forget how to remove NA columns, I'm just going to go ahead and remove them manually. Since they're still in the old file, I guess if we really need them back for some reason, we can go look at them. The only reason we might need them back is to say that the people who we didn't give the CRT to weren't somehow different beforehand. Does that make sense? I mean, really, we just tacked on the CRT. Looks like these people didn't take the CRT at all. Did they? Where did these numbers come from? 101? That's weird. Let me ask someone about that. Alright, well, assuming you have some sort of reason for that, I guess I'll keep them in, even though it looks like they have correct and incorrect scores, but nothing to base that on. Maybe this is just like I'm seeing the end product whenever you were doing it. You had something else visible. Let me just delete these real quick. Like I said, it's a pretty, usually just have to say na.action equals remove, I think is what it is, but I don't want to have to Google it when I can just take them out manually. This is my weird. Is it lazier to do it this way? It probably takes longer to do it this way. Alright, got all the NAs out. So, alright, so I'm going to first I'm going to click this little broom right here, get rid of all the different stuff I had saved from a different R session. I'm going to go to from text, import data from text base, and navigate over to where I have it stored. And I want that first row to be headers. Import. No, I don't need to. Oh. So down here it spit out some code that I can copy and paste for next time, which creates the data set. So we definitely want CRT scores as a variable. So scores equals CRT I'm going to put all of this in a sum statement. So you just comma separate all the elements and we'll sum all of them. CRT 3. So this new variable CRT scores, Oh, it actually just added up all the problems they all got right. What I really should do is row sums. X must be an array at least row sums. Let's do C bind. There we go. So these are, for participant 1, they got 2 right, then a bunch of people got none of them right, then this one got 3 right. That's the mark of a really great tutorial, is when the guy doing it has to make all kinds of guesswork. Let's see. Numeracy equals what's the best way to do this? Row means let's see. CRT. Are you talking about starting a participant 123? Probably. Alright, so the first expanded numeracy item is column 4. And the last one is column 11. So this is basically saying take CRT, and then those were already coded, so I was assuming this is okay. Alright. So this is basically saying take CRT and then subset by row, comma, column. If you leave the rows empty, it'll take all the rows. But if you specify columns, I'm saying columns 4 through 11. So when you do this, it's basically creates a new data frame that's just columns 4 through 11, but all rows, since I didn't say in the first column spot there's certain rows in there. I think I should be able to put row means there. Yeah, okay, so numeracy equals that. So now I have numeracy, I have CRT scores, and if I do CRT $ suspicion, that'll be suspicion as a variable. So we want to do the logistic regression where CRT suspicion, this is our dependent variable. We're predicting whether people become suspicious. So mod 1 equals, we're going to use the GLM function, that's the general linear model. CRT $ suspicion is the dependent variable. And for now, let's just do CRT.scores. So this is saying Y is regressed on X, and comma, we have to specify that we're doing logistic regression, can also be called binomial. Okay, you ran that line, thankfully no warnings. Let's look at the summary, mod 1. Shit. Mod 1. Alright. So, looks like CRT scores does not predict whether people will show suspicion. It's interesting. So that would mean kind of a failure on the CRT part, because it should. One of my cats is having an episode. But let's delve deeper here. Mod 2, copy and paste this GLM stuff right here. So we're regressing suspicion on CRT scores. I'm going to add in numeracy. Thank you for not throwing any warnings. Mod 2, okay, nothing significant. Yeah, so there are a few which only have dots on this, so I assume those are the ones that had to answer for 65. Some of the ones with, the ones with dots, I think are the ones took the experiment before we tacked on the CRT. Okay, so even when controlling for numeracy, the variance in whether people could become suspicious is now being accounted for by numeracy, and even the leftover variation that's unique to CRT scores is still not doing any predictive power. What was the other variable? Mod 3. Let's put this all back in there. Mod 3 equals all that. Let's add in CRT $sign condition. I think that might be the last thing to look at. Oh yeah, and study, there's incentive. That's in there too, okay. Summary, here's mod 3. Okay, so being in condition 2 affects whether you're suspicious. So if the problem is concrete, it'll increase the likelihood that you're suspicious. 2.48, that's not bad. I wonder what that is in percent. X divided by sum of 1 and sum of 1. So being in the concrete condition increases the predicted probability of being suspicious by a pretty hefty amount, about 36%, 37%. And then, and now one of my cats has to play with something. They drive me crazy. Okay. Let's look at some more stuff here. Now we're going to look at study. Mod 4. Equals all that. And then I'm going to add plus CRT study in there. Let's look at summary for mod 4. All right. So even when we're pulling out all kinds of different sources of variation from all these different variables, whether they're in the concrete condition is really the only thing that matters. Which is weird because in our study, the calculator study, numeracy mattered. Maybe because CRT and numeracy are collinear. Let's try the order in which you put stuff in matters. Let's try taking out numeracy for mod 5. Okay. That changed the intercept, which is kind of strange. Yeah, so I think the take home here, no matter how you cut it, is that the CRT is supposed to predict when you'll double check and watch your step mentally and kind of say, wait, is that right? But in this situation, this is a problem that's saying a woman born in 1942 was 114 years old in 1994. That shouldn't, if you're prone to say, all right, now wait, let's see if that sounds right, you should show some evidence of being suspicious of that if the CRT is measuring what it's supposed to measure. So I think this is evidence that the CRT needs some work, because this was a situation where it should have shown predictive validity. There's all kinds of different types of validity. Let's see. Predictive validity, which score on a scale score criterion measure. This is kind of similar. Scores on an intelligence test should correlate with your supervisor's score of ratings of how good, how smart you are. I don't know. It seems to me like it really, maybe construct validity is what I'm really thinking of. Construct validity, I think, is an umbrella term for all kinds of different psychometric properties. The degree to which a test measures what it claims or purports to be measuring. We might want to drill down on the, like, we could just say construct validity, but you know, it's another thing. What's the main finding here? So CRT, let's just say CRT by itself does not predict suspicion. Let's get a confidence interval to see how accurate was that estimate anyway. People might gripe that we didn't have a very large sample. 95% CI logistic regression coefficient R. This looks about right. So the 95% confidence interval for our slope right here, which is 0.23, ranges from -15 to +61. That's a fairly wide confidence interval, but I don't know. I don't think that really detracts. I mean, what's our sample size? 161 observations. I think that's a pretty weak rebuttal. If someone at the conference says, "Oh, but you know, were you underpowered? Did you have enough of a sample to detect an effect?" I would say, look, 161 participants should have been plenty. So I don't think that's too bad. So I'm going to go ahead and upload this on YouTube. I made the video so that you could watch it and kind of have an understanding of like what we did, and then we can follow up and talk about the different lines of code. And I think it's important to learn how to use R, especially in Tyler's lab. We use R a lot, and in one of the classes you're going to take regression, we use R in that class, so it doesn't hurt to start learning it. So let me send this out real quick.